Exercise A06 is going to try to clear out a couple of misconceptions about the size of different entities, different variables, once you start mixing together a definition of pointers, arrays, etc. So here is what we are going to do. We are going to have this little program, okay, which defines an array A1 of size 3, array of integer. Then A2 will be an array of size 3, but 3 doubles this time. V1 is a simple int variable, V2 is a double variable, and then we have P1, a pointer on int, which is initialized to the address of the first element of A1. P2, a pointer on double, will be assigned the address of the first element of A2. P3, a pointer on int, will be assigned the address of V1, and P4, pointer on double, will be assigned the address of V2. What I'm going to ask you to do now is to take the stable at the end of our exercise sheet, and I'm going to ask you to fill in the blanks for the resulting value of displaying all of those expressions that are in the first column. So you are going to do a printf %d of the expression size of A1. What do you expect to find there? Well, let's assume that an int is 4 bytes, okay? Let's assume that a double is actually 8 bytes. And I want you to start, without touching the keyboard or coding anything, to start by filling up this column here. What do you expect as value? Once you are done with that, cut and paste this code, add a printf %d for all of the size of that are here at the end of the code over here, so that you can have a program that is going to actually display the result of those evaluations. Once you run this program and it compiles correctly and runs correctly, fill in the second column. And once you are done with that, I want you to compare exactly what is happening for each column. Okay? So pause the video right now and do just this. Okay? Like, do the exercise as I indicated so far, so that you are capable to draw some conclusion here about each particular case. Here is a code that I just implemented that is actually going to allow us to test this function. This is a code from the exercise sheet. This is just a bunch of printf that are going to display all of those size of the evaluation of all those size of expressions. So let's go to the Conqueror window. We are going to actually compile this, run it. And now we need to make sense of those values. So to make sense of those values, we are going to look at the code, okay, that was here inside of our exercise sheet. And we are going to look at all of those size of expression and make sense of them. First one, size of and the name of an array. Well, when you do the size of the name of an array, you get the full size of the array, which is 3 times the size of an int. 3 times 4, 12 bytes. Same thing for A2. 3 times 8 this time, 24. Okay, a double is 8 bytes. Then we do size of V1, size of V2. These are basic variables. So the size of an int is 4 bytes. The size of a double is 8 bytes, consistent with what we observed for A1 and A2. Then we have size of P1. Size of P1, size of P2, size of P3, size of P4. All of them are equal to 4. A pointer, no matter what you point to, is stored as 4 bytes. And then we have size of star P1. Well, P1 is actually pointing to A1. So the misconception, the common misconception here is to say, well, P1 points to the array. Therefore, star P1 represents the whole array. Wrong. P1 here, if you understand the equivalence between the name of an array and the address of the first element of this array, P1 here is assigned the address of the first element of array A1. Therefore, P1 is a pointer on int, which points to the first element of this array. So what is the size of what P1 points to? The size of an int. For P2, star P2, the size will be the size of a double, because P2 is a pointer on double. Now what about P3 and P4? P3 and P4 are assigned to the address of two basic variables of type int and double respectively. Well, guess what? P3 is 4 bytes, like any pointer. Star P3 is 4 bytes, size of an int. Star P4 is 8 bytes, size of a double. So this is a good exercise to make sense actually of everything we covered so far. So I hope that you performed that exercise before to look at the solution here, and this is a good way to make sure that you didn't miss anything important in the previous exercises. And if you did, if you have some trouble feeling the stable, or you have like things that you observe now and that make sense now but you didn't expect, then you know that you have a couple of questions to ask on the forums.